Hi, the SI meteorologist Paul Dorian here with a brief discussion on the Pacific Decadal Oscillation, otherwise known as the PDO. The Pacific implies, of course, that this is a phenomenon that takes place in the Pacific Ocean, which of course is an all-important ocean. The reason we're even looking into this is because the Pacific Ocean often impacts what happens around the world. All the other oceans combined cannot fill up the Pacific Ocean, so what goes on in the Pacific is critical to the world of weather and climate. The decadal part insinuates that this is a long-term fluctuation. In fact, sometimes the oscillation between cold and warm phases with respect to the PDO lasts for 20 or 30 years. In the cold phase, the cool waters tend to wrap around in a kind of a horseshoe-shaped pattern around an inner core warm section of the Pacific Ocean, and in the warm phase the opposite occurs. Now, we have had only a handful of phase shifts over the last 100 years or so that we believe have happened. 1905 the PDO switched to a warm phase, 1946 to a cold phase, 1977 it switched to a warm phase, and there's quite a bit of evidence now that we switched to a cold phase just a few years ago, back in 2008. Sometimes it takes a few years to confirm such a thing, so I'm not saying it absolutely is now in a cold phase, but a lot of evidence is out there that suggests that we are now entering a cold phase of the Pacific Ocean. Why do we even care? Again, the Pacific Ocean has a huge impact on global weather and climate, and there are some studies that show that when the PDO shifts to a warm phase, global temperatures tend to warm up. When it shifts to a cold phase, global temperatures tend to cool down. Well, we'll now show a graphical representation of the PDO courtesy of NOAA and the Joint Institute for the Study of the Atmosphere and Ocean based out in Washington State, and also an index table that they put together for the PDO. Finally, we'll look at the current sea surface temperatures in the Pacific Ocean and see how it relates to a possible cold phase of the PDO. But here's in fact a graphical representation of the warm phase on the left and the cold phase on the right here of the PDO. And again, in both cases, it's kind of a horseshoe-shaped pattern. Here's the west coast of the United States, California coast right here. And in the warm phase, you tend to have a horseshoe-shaped pattern of warmer than normal water temperatures that kind of wrap around an inner area of colder than normal temperatures, and the opposite takes place in a cold phase, where just along the Pacific coast from Alaska down past California there's colder than normal temperatures represented here in the greens and the blues, and this kind of horseshoe-shaped pattern again wraps around a smaller area of warmer than normal temperatures. So these are the kind of patterns that scientists look for to determine what kind of a phase we're in. And again, there's some evidence now that we have shifted back a couple of years ago to a cold phase, perhaps in 2008, with colder than normal temperatures up and down the west coast of North America. Now, another way to represent the PDO is by making an index. We've seen this before with the El Nino and La Nina, where NOAA puts together an index to represent the different phases of each. And again, we just mentioned before that 1977, for example, was where we believe we entered into a warm phase of the PDO. Now notice here, from 1977 all the way down through the early part of the last decade, we had mostly positive numbers here, and positive numbers in this particular time frame represent a warm phase of the PDO. Again, we believe we shifted into a warm phase around 1977. So now, let's now go to the most recent years of 2008, 9, and here they are. Notice that from 2008 on down to the present, we have mostly negative numbers here. Again, this is an index that's put together by NOAA, and a negative here insinuates that the PDO is in a cold phase, and there's mostly negative numbers. Now, one thing I want to point out here is that when there's a cold phase of the PDO, La Ninas tend to be more frequent than El Ninas. El Nino was when the temperatures are warmer than normal in the Pacific. La Nina, colder than normal. So what happens during a cold phase, not all El Ninos go away. There are still occasional short-term cycles where the water temperatures are warmer than normal in the Pacific, which is El Nino, but La Ninas tend to dominate. Opposite holds true in a warm phase where El Ninos tend to dominate. So that's why we have a mixture of negative and positive signs, let's say, over the last 3 years. But again, the predominant index here is a negative. insinuating colder than normal temperatures or a cold phase of the PDO since about 2008. Now here's a current plot of the sea surface temperature anomalies over the globe from NOAA. And here's the west coast of North America off the California coast. And the blues here represent colder than normal temperatures, and the oranges and reds warmer than normal. This is again the current sea surface temperature anomaly chart. And notice we have that typical horseshoe-shaped pattern of colder than normal water temperature throughout much of the Pacific that are kind of wrapping around an inner core warm section of the North Pacific. So again, this kind of evidence is insinuating that we are now in a cold phase, and we'll just have to monitor this over the next several months and the next few years. Again, the significance of this is sometimes this has a correlation to global temperatures. In the cold phase manner, it often leads to colder than normal global temperatures, so we'll just have to monitor this over the next few years and see in fact how this affects the worldwide conditions. That's it for now. I'm the SI meteorologist, Paul Dorian.